Dear students, in this video I am going to explain one of the most important property or method of expressing the concentration of a solution, that is normality. This is very important method to express the concentration or find out the concentration of any solution. What is normality? The number of gram equivalent weights present in 1 liter solution is called normality. Normality is equal to number of gram equivalents divided by volume of the solution in liters. If volume of the solution in milliliters, we use that formula weight by gram equivalent weight into 1000 by V milliliters. Here units are gram equivalents per liter. If temperature increases, normality decreases for any solution. Here number of gram equivalents is equal to normality into volume of the solution into liters, and that is equal to N into V milliliters by 1000. Gram equivalents is equal to gram molecular weight divided by N. N is the basicity or acidity or charge or number of electron transferred per mole. Relation between molarity and normality. N is equal to weight by gram equivalent weight into 1000 by V milliliters. So N equal to weight by this gram equivalent weight can be written as gram molecular weight divided by N. So N equal to normality is equal to molarity into small n. Now I want to explain how to find the most important aspect in this normality, that is gram equivalent weight. Let me explain. Gram equivalent weight, the weight of an element that combines with 1 gram of hydrogen or 8 grams of oxygen and 35.5 grams of chlorine is called gram equivalent weight of an element. Here I will explain one example, H2S. Here we want to find the equivalent weight of sulfur. 2 grams of hydrogen is combined with 32 grams of sulfur. So 1 gram of hydrogen combined with 16 grams of sulfur. So sulfur equivalent weight in this compound is 16 grams. So likewise you can understand the remaining equivalent weights of an element. Now note, the important note is the equivalent weight of any element changes from compound to compound. Next, for acids, this is very important. Equivalent weight equal to molecular weight divided by basicity. What is basicity? Number of replaceable hydrogens in an acid is called basicity. Let me explain what is the basicity of an acids with an examples. Here hydrogen chloride. The basicity of hydrogen chloride is 1 because number of replaceable hydrogens in acid, hydrogen chloride acid is 1. Therefore molecular weight is 36.5. So equivalent weight is 36.5 by 1, that is equal to 36.5. Like that, the remaining acids basicity are also given here. H3PO4 phosphoric acid basicity is 3 and 98 is the molecular weight. So gram equivalent weight is equal to 98 by 3, that is equal to 32.6. And pyrophosphoric acid H4P2O7 basicity is 4. So 178 is the molecular weight. 178 by 4, that is equal to equivalent weight is 44.5. Exemption. Some exemptions are there. Suppose if you take hypophosphorus acid H3PO2, you can understand the basicity is 1. Even though this acid contains 3 hydrogen atoms, but the basicity is 1 because if you observe the structure, only one replaceable hydrogen, that is OH. In OH, that hydrogen is replaceable with bases. So therefore H3PO2 basicity is 1, molecular weight is 66. So equivalent weight is gram equivalent weight is 66 by 1, that is equal to 66. In phosphorus acid H3PO3 also, you can look at the structure and understand the basicity is 2. Replaceable hydrogens in phosphorus acid is 2. So gram equivalent weight is 82 by 2, that is equal to 41. Likewise, in boric acid and pyrophosphorus acid, all these acids we have the different number of hydrogens not equal to basicity. So sometimes basicity is equal to the number of replaceable hydrogens, and sometimes not, because of the structure and so many aspects are there. Next, for carboxylic acids, the acids contain COOH group is called carboxylic acid, we all know that. So equivalent weight is equal to gram molecular weight divided by number of COOH groups. Example, acetic acid CH3COOH, only one COOH group is present, so equivalent weight equal to gram molecular weight 60 divided by 1, that is equal to 60, that is the gram equivalent weight for acetic acid. And oxalic acid, here also COOH.H2O, 2H2O, this is the oxalic acid structure. You can find the only two COOH groups are present in oxalic acid, so equivalent weight is 126 by 2, that is equal to 63. Next, we are going to understand what is the, for bases, acidity of bases. So equivalent weight is equal to gram molecular weight by acidity. Acidity is the number of OH groups present in the base. NaOH, there is a one OH, so equivalent weight equal to molecular weight divided by 1, so 40 is the gram equivalent weight for the sodium hydroxide. And similarly, CaOH twice, it has two OH groups, so therefore gram equivalent weight is 37, and acidity is 2. For aluminum hydroxide, acidity is 3. So therefore number of OH groups is equal to acidity for bases, but very important case for Lewis bases, equivalent weight is equal to molecular weight divided by number of donated protons, donated pairs, electron pairs donated in NH3. So electron pair donor is called Lewis bases. So NH3 is electron donor. So here NH3 donates only one pair, because on nitrogen we have one lone pair. So equivalent weight equal to gram molecular weight divided by 1. In hydrogen, the equivalent weight is equal to molecular weight divided by 2. Note, in case of neutralization equation, equivalent weight equal to gram molecular weight divided by number of hydrogens replaced. So here very important is, this is the neutralizer reaction, hydrogen sulfuric acid reacts with sodium hydroxide. Here only one hydrogen is replaced, so gram equivalent weight equal to molecular weight divided by 1. And in the second example also, here two hydrogens are replaceable, so here very important reaction it is H3PO4 plus 2 NaOH gives rise to Na2HPO4. Here only two hydrogens are replaced, one hydrogen remains its place as it is, so replaceable hydrogens are only 2, that's why equivalent weight is equal to molecular weight divided by 2. So that is the particular cases we are discussing. Next, for ions. For ions, how can you find the equivalent weight for ions? Equivalent weight equal to gram molecular weight divided by charge on the ion. For Fe2 plus ferrous ion, equivalent weight equal to molecular weight divided by 2, and chloride ion equivalent weight equal to molecular weight divided by 1. Why we use 1? Chloride ion has only 1 minus on his charge, so 1. For salts, it is very important. For salts, equivalent weight is equal to gram molecular weight divided by total positive or negative charge in the salt. For NaCl, it has ionized and it gets Na plus and Cl minus, so charge on the cation is plus 1, so molecular weight divided by 1 is the formula to find out equivalent weight. For CaCO3, it is molecular weight divided by 2, and aluminum sulfate, it is a molecular weight divided by 6. Like that we can understand the remaining ions equivalent weights. For oxidizing and reducing agents, this is very important part as far as the gram equivalent weight is concerned. So gram equivalent weight is equal to gram molecular weight divided by total number of electron transferred or change in oxidation state per mole. So KMnO4, potassium permanganate, molecular weight is equal to 158. In acid medium, MnO4 minus ions gets it changes into Mn2 plus. Here in the MnO4 minus ion, the manganese has plus 7 oxidation state. In Mn2 plus, it is equal to the charge, that is plus 2. So here plus 7 to plus 2, the oxidation state changes to plus 7 to plus 2. That's why here 5 electrons are absorbed. So that's why the 5 electrons is transferred in this equation. So gram equivalent weight is equal to molecular weight divided by 5. Plus 4. So potassium permanganate has different electron transfer in different conditions, and basic Bayer's reagent is a cold diluted alcoholic KMnO4 is a Bayer's reagent. It is used to detect unsaturated carbons in hydrocarbons. And potassium dichromate K2Cr2O7 in acid medium, the transfer number of electron transferred in acid medium is 6 electrons. So equivalent weight is equal to 294 by 6, that equal to 49. And in Morse salt, very important salt, that is FeSO4 NH4 twice SO4 7H2O hydrated ferrous ammonium sulfate is called Morse salt, and molecular weight is 398. In this Morse salt, when an equation is happening, the iron oxidation stage is +2 to +3. So it is an electron transfer, number of electron transferring during this equation is 1. So equivalent weight equal to molecular weight divided by 1. So 392 by 1. So for any this kind of equations, you must understand gram equivalent weight is calculated by molecular weight divided by different formulas are used for acids and bases and salts and ions, and some kind of oxidizing reagents and reducing agents. Thank you so much.